Okay, so if you watched the first video, you should have learned about the three main types of transformations and how those look towards our function. If you haven't watched that video, go back and watch that video first, and then you can show how those transformations actually work. So in this question, I just have a random parent function. So I have y equals f of x. It's not any specific function, it's just this weird looking kind of duck thing. So we're going to use that parent function to sketch the new transformation graphs. So you can see here I've made a list of my points. This is to help me see how these points change because of the transformations. So we did this with a table of value. Now I'm going to show you how to do it with a list of points in case you don't want to make that table of value. So the first thing we need to do is we need to look at our new function and see what transformations they are applying. So I know if I'm outside my function, I'm affecting the y-axis. And in this case, I'm making all my y values increase by 3. So if I have my original point, which is just xy, that's my point on my parent graph. On my new graph, I know that y is going to be increased by 3. I need to move that y value up 3. When I look at the inside, I have to remember, the inside lies. So even though the inside is telling me that I'm subtracting 2, how that looks on my graph is I'm actually taking all of my x values and I'm adding 2 to move my graph 2 to the right. So we're going to apply these two transformations to all of our points from our parent function. So they're the ones in red here. So what used to be negative 4, 2, so negative 4 plus 2 is going to be negative 2. 2 plus 3 is going to be 5. So I'm going to have negative 2, 5. What used to be negative 2, I'm adding 2, 2 is now 0. What used to be negative 2, I'm adding 2, 2 is now going to be 1. I'm at 0, 1. Again, negative 1 plus 2 is 1. Negative 2 plus 3 is 1. 2 plus 2 is 4. 4 plus 3 is 7. So we want 4 and 7. Last but not least, 5 plus 2 is 7. 3 plus 3 is 6. So we over here at 7 up to 6. So we have our parent function, that ducky looking shape thing, and we just took it and we moved it up on our scale and over to the right. But the shape of the graph did not change at all. It's still the exact same shape. Now we're going to do that exact same thing with a stretch and compress this time. So you can see here, I'm outside my function. When I'm outside my function, that means I am changing my y value. So this means I need to take all of my y values and I need to triple them. So again, on my original function, my parent function, it was xy. But now this transformation says triple those values of y. So instead of y, I'm going to actually have 3y. And then inside, inside lies to me. I can see a 2 here, but that actually means that I need to times everything by 1/2. I need that reciprocal value of 2. So that means I need to take all my x values and I need to divide them by 2 or times them by 1/2. So my new points on this graph are going to be 1/2 of negative 4. This is going to give me negative 2. And then 2 times 3 is going to give me 6. So negative 2 and 6, I have my new point way up there. 1/2 of negative 2 is going to give me negative 1. Negative 2 times 3 is going to give me negative 6. So I'm at negative 1 down to negative 6. So you can see I have stretched that line a lot. It used to be this little line over here, and now it's this big, nice, long line. So you can start to see that stretch happening. What used to be -1 is now -1/2. What used to be -2 is -6. So I need -1/2 and -6. It's going to be approximately there-ish. All right, then we're going to have 1, 12. Uh-oh, this is going off my graph a little bit. So I'm 1, 12, so I'm way up here somewhere. 1/2 of 5, so that's going to be 2.5. 3 times 3 is 9. I need 2.5 and 9, so about there. So when we play connect the dots, finishing off this graph, you can see that line has changed a whole heck of a lot. It is a lot longer. And we're up there, and then we're kind of there. So we still have our duck shape. It's just been stretched a whole lot. It got a lot taller and a lot skinnier because of those stretches. Stretching it 3 times taller and half as fat. So I want you to take those two ideas and apply them to this last graph here. See if you can draw the transformation with this graph.